Hey everyone, in this video we are going to learn how to solve literal equations. Now a literal equation is just an equation with variables in it. Think of those formulas you have used in math or science class. They're all great examples of literal equations. For instance, the area of a rectangle formula, which is area equals base times height, or A equals B times H. That is an example of a literal equation, and the first that we will take a look at. So if you knew the area and the height, how would you find the base? Well, most of us would plug in the value for the area, the value for the height, divide both sides of the equation by the height to solve for the base. But what if we looked at that problem differently? And instead of plugging in first, what if we rearranged the formula first? So if we took A equals B times H, and we wanted to solve for the base B, we would divide both sides of this equation by H, and we'd have A over H equals B. Or if we wanted to switch the sides, B equals A over H. Now, same formula, but we rearranged the variables to isolate B. So now the formula reads B equals A divided by H. The advantage of this, imagine you had a set of problems where you were solving for the base of different rectangles after you were given the area and the height. By rearranging the formula first, now we can plug into this new formula, get the answer for each of those questions more directly with less time and effort. So that is the advantage of knowing how to solve a literal equation. Our goal is to rearrange the formula to solve for a specified variable. In this case, it was the base B. In our next example, we are going to take the same literal equation, but solve for different variables so we can see how that changes our answer. The equation is ax plus b equals c. Notice that literal equation has 4 different variables in it, a, b, c, and x. In the first question, they're asking us to solve for b. In order to do that, we can subtract ax from both sides of the equation, and we have b equals c minus ax. In the next part, they're asking us to solve for a in that same equation. Now solving for a, we would subtract b from both sides of the equation. We would have ax equals c minus b. I'll scroll down, and we want to solve for a, so we can divide both sides of the equation by x. And we have a equals c minus b divided by x. After solving for a, the equation looks a little bit different. We have a fraction on the right side compared to the first example where it was just b equals c minus ax. And that is all dependent on the variable we are solving for. But we still have the same 4 variables in our answer in both examples, just presented in a different way. Also important to point out, we did not solve for x in either of these examples. Oftentimes, our go-to in algebra is to solve for x, so just pay attention and read questions carefully, maybe underline the variable that they're asking us to solve for so that we don't make that mistake. Next up, using the given formula, express v in terms of I and r. So the formula they gave us is I equals v divided by r, and we are solving for v. So we go to the formula, we can multiply both sides of the equation by r. Now on the left side, when we go to write the product of r and I, we do typically put our variables in alphabetical order. So we'll write that as I times r equals v. Since the r variables on the right side will simplify. And the reason for writing the variables in alphabetical order in the same term is if there are multiple terms in the literal equation, by writing the variables in alphabetical order, it might be easier for us to identify if there are like terms, and then we'd be able to combine them and simplify our answer. Now solve the equation for b. And the equation they gave us is v equals 1/3 times b times h. So this is a volume formula. We want to solve for b. So the first thing we're going to do is move the 1/3 to the other side of the equation. Now, it is very tempting for us to just divide both sides by 1/3. Now, don't write this, just watch. And what we'd wind up with is v divided by 1/3 equals b times h. While mathematically, we did not do anything wrong by dividing both sides by 1/3, we did create a complex fraction on the left side of the equation. And in terms of simplified answers, we do not consider a complex fraction, or a fraction inside of a fraction, to be a simplified answer. So then we would have to do a bit of extra work here, multiply the numerator and the denominator by 3 to simplify it. But let's go back to the original equation. Maybe there's a different way to move the 1/3 to the other side of the equation that would prevent that from happening. And instead of dividing by 1/3, we can multiply both sides of the equation by 3. The 1/3 and the 3 would simplify. And we are left with 3v on the left side equals b times h on the right side. Then we're going to solve for b by dividing both sides of the equation by h. And we have 3v divided by h equals b. And we've rearranged the formula to isolate the b, or solve for b. Solve the equation for L. So notice L is only in the last term here, the equation being a equals pi times r squared plus pi times r times L. So first we want to move the pi r squared term to the other side of the equation. We can do that by subtracting pi r squared on both sides. So then we have a minus pi r squared equals pi r L. Then we want to solve for L. So this is pi times r times L on the right side of the equation. And I'm saying it very specifically because I'm using the word times, which indicates that we are multiplying these three pieces together. So if we want to solve for L, we then need to divide both sides by, in this case, pi r to solve for L. So we would divide by pi r on both sides to get a minus pi r squared divided by pi r equals L. And we've solved the equation for L. Right? We've rearranged the terms. Using the given formula, express m in terms of b, c, x, and y. So the formula they gave us is y equals mx plus b all divided by c. So first step here, multiply both sides by c. The c in the denominator will cancel with the c we're multiplying by, so we get cy equals mx plus b. Now let's just remind ourselves we are solving for m here. So then we can subtract b from both sides of the equation. Cy minus b equals mx, or m times x, which is a reminder that we are going to divide both sides by x in order to solve for m. So we have cy minus b over x equals m. And we've rearranged the formula they gave us. So now m is expressed in terms of the other four variables, b, c, x, and y. solve the equation for y sub 2. This example now has subscripts on some of the variables, which makes them different variables, right? So y sub 2 and y sub 1 are different variables. And this is the slope formula that we find, or we use to find the slope between 2 points. So to solve for y2 here, I'm going to make this m over 1 and think about cross multiplying for our first step. So then we have m times x sub 2 minus x sub 1 equals y sub 2 minus y sub 1. We can distribute the m on the left side. So m times x sub 2 minus m times x sub 1 equals y sub 2 minus y sub 1. And to solve for y sub 2, we can add y sub 1 to both sides of our equation. So we get m times x sub 2 minus m times x sub 1 plus y sub 1 equals y sub 2. So here we were able to rearrange the slope formula to isolate or solve for y sub 2 instead of m. Now let's take that same slope formula but solve for x sub 2 instead of y sub 2. X sub 2 is in the denominator, so that may change our approach as we go through this, but we can start the same exact way, m over 1 and cross multiply. So we have m times x sub 2 minus x sub 1 equals y sub 2 minus y sub 1. X sub 2 is inside of the parentheses, so we have two choices here. We can either distribute the m like we did in the previous slide, or we can divide both sides of the equation by m. I'll stick with the distribution step here, but either way we would get a correct answer. So m times x sub 2 minus m times x sub 1 equals y sub 2 minus y sub 1. Then we are going to add m times x sub 1 to both sides of this equation. So m times x sub 2 equals y sub 2 minus y sub 1 plus m times x sub 1. I'll scroll down because we need one more step here, which is to divide both sides of the equation by m. We get x sub 2 equals y sub 2 minus y sub 1 plus m times x sub 1 all over m. We've rearranged the slope formula to now solve for x sub 2. And here we see our answer. Now, one thing that we could do with this answer is we could write it to look different. Maybe we write it so that we separate all the terms in the numerator and put them all over m. So y2 over m minus y sub 1 over m plus m times x sub 1 over m. It would still be a correct answer. It would just look different, which leads us into our next slide. Two students solve the formula for L in different ways. Are both solutions correct? So we have the perimeter formula here for a rectangle. P equals 2 times the quantity L plus W. So student 1 chose to divide both sides of the equation by 2 first. They got P over 2 equals L plus W, and they subtracted by W on both sides. They put the L on the left side, right? So they did switch sides, and they wrote L equals P divided by 2 minus W. Whereas student 2, on the other hand, chose to distribute the 2 out first, then subtract the 2w, then subtract the whole left side of the equation by 2, and again, writing L first, they wrote their final answer as L equals P minus 2w all over 2. Both of these students took mathematically valid steps to solve the equation for L, which means that both of these answers are correct. So are both solutions correct? Yes. But now we have to address the fact that they look different. How can we check to see if they are truly the same? And this comes down to our ability to work with fractions. So let's say we took the answer on the left side and we put w over 1 and we wanted to combine those two terms. Well, we can do that with a common denominator. So 2 multiplied by 2 on the numerator and the denominator. So this would become p over 2 minus 2w over 2, which is p minus 2w over 2. That matches the answer student 2 got. And if we wanted to go in the reverse direction and take student 2's answer and try to match it up to student 1's answer, well, we can separate the terms in the numerator over 2, so p over 2 minus 2w over 2. And then we can simplify that second term to get p over 2 minus w, which is exactly student 1's answer. Now, why this is important is because for literal equations, we can sometimes have multiple representations of the same answer. And if you look at an answer key, maybe they only have one of those answers written down. And instead of thinking that we don't know how to solve literal equations, we can take 30 seconds or so and try to redefine our answer to match the given answer. And we saw two ways to do that. We can either find a common denominator to combine terms, or we could separate terms and simplify. Also, if this was a multiple choice question, only one of these answers would be a possibility, right? They wouldn't put both correct answers as answer choices. So if we solved it one way, let's say like student 1, but the answer was presented like student 2's answer, we'd have to be able to match our answer to the answer that was given as one of the choices. So our last example, using the given formula, express a sub n in terms of a sub 1, n, and s. Again, we have subscripts here on the a variables. We're asked to solve for a sub n. So, first step we can take here is multiplying both sides by 2 over n. It's going to be the most direct way to do this. The n over 2 and the 2 over n would simplify. On the left side, we have 2s over n equals a sub 1 plus a sub n. And then to solve for a sub n, we would subtract a sub 1 on both sides of the equation. And we'd have 2s over n minus a sub 1 equals a sub n. And there we have rearranged the formula to solve for a sub n. Now let's take that same equation and see if we can solve it to get a different looking answer. So let's say we took s equals n over 2, a sub 1 plus a sub n. Now let's say you decided as a first step to multiply both sides by just 2. So the 2 and the 2 would simplify on the right side. We'd have 2s equals n times a sub 1 plus a sub n. And then maybe you decided to distribute, so 2s equals n times a sub 1 plus n times a sub n. Then you could subtract n times a sub 1 on both sides. Get some more room. 2s minus n times a sub 1 equals n times a sub n. And then we can divide both sides by n. And we'd have 2s minus n times a sub 1 over n equals a sub n. Now, that answer looks different than the first answer we came up with, but we followed mathematically valid steps, and we could easily show that these answers match. We can take the answer we just got of 2s minus n times a sub 1 over n, separate it into two fractions, simplify, and we would see it was equal to that first answer we got. But this is where some students can get confused with literal equations because of the fact that there are multiple representations of the same answer. Whereas when you're solving a linear equation with numbers in it, if the answer was x equals 3, even if you took a different set of mathematically correct steps, you still got x equals 3 as your answer. So literal equations take practice, right? The idea, the mindset of rearranging these formulas, we still will have the same variables that we started with in our answer, and we just have to make sure we're taking mathematically correct steps to do that rearrangement. So the more of these you see, the better you're going to get with them, because you're going to see different things happening in each example. So practice with this, and I'll see you in the next video.